So looking at number 7 from worksheet 1. First of all, change it to theta equals 3 pi over 4. Because theta equals 2 pi over 3 we already did, so we don't really need to do that again. So 3 pi over 4 would be right there. And all the points that have that angle would be that line. But when we go to the r theta graph, I want all the points that are at 3 pi over 4. So 3 pi over 4 there in the second quadrant. And that graph is only half right. What's wrong with that? Yeah, I need to go all the way, because if r is negative, we could still say these points over here in the fourth quadrant have an angle of 3 pi over 4. That's weird to think of it like that, but if they have a negative radius, they would end up in quadrant 4. Let's see, number 5. Well, yeah, let's do number 8. Excuse me, looking at the columns right there. Alright, so we're thinking about graphing rectangular coordinates. Period is 2 pi over b. The period's pi over 2. This is going to be really squished up cosine graph. An amplitude of 5. And I got to fit it all in between 0 and pi over 2. So there's one cycle. And even when we did these, we usually wanted 2 cycles. So there's 2 cycles. But that's not enough for my r theta graph, because I need to get all the way to 2 pi. So 2 more cycles. Let's see, I'm not going to label all the points. Maybe I'll get started. Theta is 0, r is 5. Now here's another one. When we first did this, we kind of had to just go point by point and see what happens. Now we're revisiting the old stuff, but now we know, maybe we should have said this from the get-go, what shape is this going to make in polar land? An 8-petaled rose. And maybe that makes sense, because there's 1, 2, 3, 4, 5, 6, 7, 8 peaks or valleys, and those peaks and valleys will make the rose. So one of them's at 0, 5. This one's at pi over 4, negative 5. Now, I don't know if you want to keep going piece by piece like that, because then there's one at pi over 2. This shows you the order that they're drawn in, which is, I don't know, maybe interesting. 3 pi over 2, no, that's 3 pi over 4, negative 5. So when the calculator draws them, it doesn't draw them maybe in the order you think it draws them in. Maybe it would be good to see this. Well, let's draw it by hand, and then we'll see how the calculator draws it. So if I was drawing by hand, this is what it would do. A to B, C to D. Now, you usually aren't going to draw it that way, especially if there's 8 of them. You know they're going to be equally spaced. And so you just figure out what the spacing is. I think I drew them in order. Like I said, if you really wanted to, you could watch the calculator draw it. Well, that did it quick. I think if I change it to that, you can change the calculator into polar setting. And let's watch it sketch. So everybody watch the calculator sketch in order. It'll start over here at A, and then it'll go to B, and then it'll go to C. And now it does it pretty quick, but it reminds me a little bit of the old spiral graph thing that you had as a kid where you stuck your finger or your pencil in the hole and did the little dealio, and that's what it made. Calculator is also fun because you can put crazy graphs in there, and now that you know how to make crazy graphs, like what if I wanted there to be 12 petals, what would there have to be? 6. Or what if they wanted to be 20 petals? So let's see what happens with this. And at some point it gets too ugly. It's just all crowded up and gummed up. And this may be the point we reach there. Yeah, there's our 20 petaled rose. Looks like a explosion of some sort. But polar graphing with the calculator is kind of fun because you can play around and make all sorts of pretty pictures. So 8 petaled rose, but that was a good example of one where we originally could have done that without knowing it was an 8 petaled rose. We could have gone point by point by point by point by point. We could still do that, but we combine that with what we already know, and it just makes life a little easier. Let's see. Number 9. How many petals is that going to have? 3, remember, because if n is odd, then it has 3 petals. Period would be 2 pi over 3. Oh, kind of tricky to figure out where that is on this graph. 2 pi over 3. 4 pi over 3. Doing this helps us figure out where the first petal is. Remember we said sine doesn't start at 1, sine starts at 0. So our first petal is at pi over 6. I think that's what our grid is. So there's our first petal. Then we got to figure out where the other petals are. Well, they're equally spaced, so some people can do it visually. Other people want to go a little more slowly here. They say, well, at pi over 2, that would be the peak. That would be a petal location. Pi over 2, negative 4. And then you can guess where the, I did this yesterday. 1, 2, 3, 4, 5. So this is the one that's wrong. I went out too far on that first pedal. That's a 5-length pedal, and this is a 4-length pedal. The 4 one's right. So this one should be to this point, not the far point. Let's see. I guess we could keep going on this graph if we didn't know where the next one was. Looks like at 5 pi over 6. We're out at 4. 5 pi over 6. 1, 2, 3, 4. And now we've got our 3-pedaled graph. And I guess if this was the assignment, we would need to finish out the picture here. And there's a 3-pedaled sine graph. Let's do number 10, and then we'll talk about the format of the test. R equals 1/2 theta. So on a rectangular graph, I haven't done one of those, but as theta gets bigger, r gets bigger. So let's just pick some points. If theta is 0, r is 0. If theta is pi, it's going to be a spiral. R would be pi over 2, which would be, what, 1.57 something? So 1.5. If theta is, whoops, I did something wrong. Pi, comma, pi over 2. So it's a line on the xy graph. So if theta is 2 pi, then r is pi. Pi is 3.14. And so it's just linearly increasing like that. We come over here, start at 0, 0. At pi, we'd go out 1.5. At 2 pi, we'd go out 1, 2, 3, and 3.14. So yeah, it spirals around. And it would keep going if you let it keep running. So to 2 pi, we'd stop there. To 4 pi, we'd have to go around again, but it would just keep getting bigger and bigger on the spiral. All right, let's talk about what's on the test. The only assignment for today is one extra problem, and that would be number 4 with the big table on it. So that's your only Wednesday homework right there. Or to finish up whatever else you hadn't done.
So everything else is
Correct. So there's a whole bunch of problems that we omitted, skipped, whatever. So yeah, you don't have to have the whole thing done, just what we've assigned. All right, well the test is all graphing, but there's a little bit different format of the problems. There are 2 where we want you to graph on rectangular, then on polar. That was like worksheet 1, where you graph it the old way and then use the old way to help you graph it the new way. but you also know more information now, so you can use your knowledge to help you with the polar graph. There's one that's graph using table of values. So no rectangular, but just a table of values. That's like worksheet 2. That would be the only problem on today's assignment, where we just give you a big table, have you fill everything in, and then do the graph. And then there's one where it just says graph. So that's where you kind of have to know the shape, plot a few points to get the shape correct, but that's like worksheet 3. Now you could kind of treat all of them like worksheet 3 because you know what the shapes are, but we still want to see a table of values for one of them, and we want to see a rectangular graph for 2 of them. And then there are 5 matching problems, also like worksheet 3. So here's your point values, total point values. So the graphing ones are 10 points each, and the matching are 2 each. So 50-point test. Should go well, plus your projects, which are really good as well. So you end the year on an uptick, hopefully. All right, all the answers are posted in Schoology. You guys are in here if you want to check. They're up here as well. And you've got a few minutes left to look over things, and we'll test tomorrow.